First of all, Viking is a fantastic venture, and I mean that literally. It's probably the most sophisticated spacecraft ever designed for any purpose. It's going to Mars, it's going to land on Mars, and it's going to orbit around Mars at the same time.
At least 5 times out of 10, when I tell people that I'm called the angry astronaut, they ask me, why are you so angry? There are a number of reasons, but one reason that I seldom talk about is the fact that the scientific community is so incredibly narrow-minded in the face of overwhelming evidence. Indeed, since 1976, we have had an enormous amount of evidence to suggest that there is active biology on the red planet, something that is very seldom talked about, especially in present-day documentaries. But it is true. Viking is the only spacecraft that we have ever sent to another planet that had life-detecting equipment on board, life-detecting experiments, that is. And these experiments produced positive results over and over again at 2 different locations on the red planet. The only experiment that produced negative results were the experiments that the landers were not really designed to detect. That is, the presence of organic molecules. But every other experiment carried out by Viking showed the presence of life. And again, repeatedly. And the only reason that the history books do not show that life was discovered on the Martian surface in 1976 is because the scientific community turned around and said that the results of the experiments were inconclusive, even though they performed exactly as designed and produced the positive results that NASA was looking for. All of a sudden, scientists turned around and said the experiments did not provide enough information, that there's no way, actually, that they could have conclusively detected life on the surface of Mars. And interestingly enough, NASA has never sent another probe to any other planet with similar life detection experiments on board, almost as if they know that life is there already and there's no point in looking again. But regardless, the discoveries that were made by the Viking landers are not the only evidence that we have. Evidence continues to pile up that not only was Mars a very habitable place and very suitable for life to evolve and thrive across its surface, also we have a great deal of evidence to suggest that that life is still there, still thriving, and could present a serious threat to Elon Musk's expedition to Mars, which is likely to happen in the next 10 years, or maybe even less. So first of all, for those of you unfamiliar with some of the videos that I've produced in the past about the Viking experiments, you may be wondering, what exactly did we find back in 1976? Well, the Viking label release experiment, which by the way was designed by doctors Gilbert Levin and Patricia Stratt, who incidentally both claimed that they detected life after the experiments were concluded, was one of 3 life detection metabolic tests on the 1976 Viking mission to Mars. But these were not the only life detection experiments on the Viking. There were also the gas exchange experiment, which tested for microbial life exposed first to humidity only, and then to water, and then to immersion in a complex chicken soup of organic nutrients and supplements, and then the pyrolytic release experiment, which was designed to test for microorganisms that photosynthetically incorporated carbon-14 and or CO14 in a simulated Martian atmosphere in an environment with and without the addition of water. There was also a 4th experiment called the Gas Chromatograph Mass Spectrometer, or GCMS, which was included to analyze organics expected to be widely present on the surface of Mars. While not a life detection experiment per se, it was believed that if life existed on the planet, planet organics would be detected by the GCMS and serve as confirmation of life. By the way, this was the experiment that produced inconclusive results, but the other 3 experiments produced positive results, the label release being the most compelling of all of these experiments. This experiment was based on the belief that early Mars and Earth possessed similar primordial environments, each of which produced organic compounds that were then available for the genesis of life and its subsequent metabolism and evolution. So in this experiment, a nutrient solution consisting of these organic compounds tagged with carbon-14 was added to a sample of Martian regolith, and then the mixture was continuously monitored for the evolution of radioactive gas, because if the compounds were consumed, then the carbon-14 would bond with oxygen, creating radioactive CO2. By the way, this is a modified experiment that's used on Earth to detect the presence of bacteria in drinking water. It never produced a false positive after many test experiments on Earth, and when it was sent to Mars, lo and behold, it produced positive results with both the Viking 1 and Viking 2 landers. But NASA was not satisfied. They thought that perhaps there might be some sort of abiotic chemistry consuming the nutrients. So to prove that it wasn't abiotic, Dr. Levin and Dr. Stratt heated the samples up to 160 degrees. In other words, a level that should have been able to kill any bacteria that were present in the regolith, and retested the samples, and they produced negative results. Nothing was consuming the nutrients after they heated it to 160 degrees Celsius. However, that still wasn't enough for NASA, so what Dr. Levin did after that is heat the samples up to a lesser degree, to a degree that should have killed some of the bacteria, but not all of them, and so therefore a lesser amount of the nutrients should have been consumed as a result. Lo and behold, it had a 60% drop in consumption, but it didn't disappear completely. And then NASA still wasn't satisfied. They thought that perhaps ultraviolet radiation hitting the surface of the Martian regolith might somehow be producing these results. So Dr. Levin had the Viking lander flip over a rock that would have shielded any regolith underneath it from the effects of ultraviolet radiation, and tested the regolith underneath the rock. And lo and behold, it produced a positive result. I can't imagine any evidence that would have been more compelling at the time, and yet it still wasn't enough. So perhaps you could argue that these experiments weren't enough. Perhaps, as skeptics are fond of saying, extraordinary claims require extraordinary evidence, and this wasn't extraordinary evidence. Well, at the time, it was not definitively known whether or not Mars was a suitable place for life to evolve in the first place. It wasn't known for certain whether or not water existed in liquid form on the surface, whether or not that water might have been subjected to heat, and whether or not it was salty water. Those are important elements to the evolution of life, at least here on Earth. But since that time, many more discoveries have been made to suggest that Mars, at least in the distant past, was a very suitable place for life to evolve and thrive. Today, Mars, of course, is a chilly desert of rock and dust, but 4 billion years ago, we know for certain now that the planet had rivers, lakes, and even oceans with sandy beaches. And the latest discovery to confirm this comes from China's Zhurong rover, which recently revealed the first evidence of one of those long-lost Mars beaches, finding shallow, sandy slopes perfectly preserved about 10 meters beneath the Martian surface. Ground-penetrating radar aboard the rover measured thick layers of sand sloping gently upward towards the rocky shore as if washed up by ocean waves. Quote, "The structures don't look like sand dunes. They don't look like an impact crater. They don't look like lava flows. That's when we started thinking about oceans," according to Michael Manga, a University of California, Berkeley professor of Earth and Planetary Science and co-author of a study that proved the existence of this beach. Quote, "The orientation of these features are parallel to what the old shoreline would have been. They have both the right orientation and the right slope to support the idea that there was an ocean for a long period of time to accumulate the sand-like beach. Therefore, there was liquid water on the surface of Mars for a very long period of time. It was salty water and it was warm water, all of which are ideal environments for life to evolve and thrive." But it gets even more convincing than that. Zhurong spent about a year trundling along the base of a steeply sloped rock outcrop at the edge of a white flat plain. From the rover's point of view on the ground, this ancient shoreline on Mars seemed to lie within a 3,300 kilometer wide impact crater called Utopia Basin. It is, in fact, the largest known crater in the entire solar system. Scientists had speculated that Utopia Basin might once have held an ancient ocean, and they thought the escarpment overlooking Zhurong's route might once have been its shoreline. And now we have considerable evidence of a salty ocean in the Utopia Planitia region. Now, of course, this alone isn't proof that life existed, only that it was habitable, but interestingly enough, the Viking 2 lander and its positive experiments were also made in the Utopia Planitia, precisely where this ocean existed. And in the Chrysa Planitia, where the Viking 1 set down, well, we now know that that region was submerged beneath water as well. And the evidence gets way more compelling than this. First of all, we need to talk about more evidence of existing life on Mars. For one thing, formaldehyde was detected by the European Space Agency's Mars Express orbiter. This is a chemical that can sometimes appear abiotically, but under most circumstances is created by biological processes. Then you have an unusual concentration of oxygen in the atmosphere that was detected by the Curiosity rover. Again, perhaps could be produced abiotically, but far more likely that some biological process is creating it. And then the unusual high concentrations of methane that were also detected by the Curiosity rover. Now, an active geology, in other words, a fair amount of volcanism, can create methane abiotically. However, there's very little evidence to suggest that Mars is that active anymore. Even though there may be some low-level volcanism going on Mars, and there's evidence that there may have been one eruption in the last 50,000 years or so, there's very little evidence to suggest that there's active geology going on that would produce a substantial concentration of methane in the Martian atmosphere, especially not seasonally, which is when the Curiosity rover detected the presence of this methane. During the summer months, one would expect to find spikes in methane being produced by life that would naturally flourish during these times, and then that methane would drop off during the cold winter months. You wouldn't expect to find geology suddenly becoming active during summer months. It makes very little sense and doesn't correspond with the data that we've gathered thus far, and the evidence continues to pile up aside from that. In terms of past life existing on Mars, a recent discovery that was made last year when an unusual looking rock was examined by the Perseverance rover, well, the evidence for past life became even more compelling at that point. Again, not enough to satisfy the scientific community, but very, very intriguing. The rock has been informally called Chayava Falls after a waterfall in Arizona, and it is packed with organic molecules, the molecules that were not detected by the Viking experiment that really wasn't designed to detect them, but now we know for certain that Mars has organic molecules. And it's also laced with parallel white veins, and between the veins are millimeter scale whitish spots with dark rims. Let me explain why all of these things are intriguing. First of all, the organic molecules are very significant, but on top of that, the veins are composed of calcium sulfate, which precipitated like limescale when liquid water ran along fractures in the subsurface. Veins like these are common in Martian sedimentary rocks. Curiosity saw plenty of them. They're not exactly biosignatures, but they normally represent habitable conditions in rocks on Earth. But what's more significant is the so-called leopard spots, little white spots with black rims that look like a tricolored leopard spot, at least according to the researchers. They analyzed these spots, making use of instruments that determine the chemical recipe of materials, and it turned out that these rims contain iron phosphate. And on Earth, rings with similar texture and chemistry are linked to ancient microbial life. As a matter of fact, we are unaware of any processes that can form these leopard spots other than microbial life. Now, perhaps there's some sort of unique process on Mars that creates features that mimic these leopard spots, but once again, we are starting to press the boundaries of believability here, and it goes on and on. For example, Curiosity's recent detection of pure sulfur on the surface of Mars. We're not talking about sulfur associated with geological activity or volcanism, but rather the types of sulfur compounds that tend to be left behind by microorganisms that are metabolizing various types of nutrients and other substances, and sometimes leave behind pure sulfur in their wake. Again, this could be abiotic, but the evidence is piling up so much at this point that I don't see how scientists can be reasonably and seriously skeptical about the presence of life at this point. How many different unlikely abiotic processes are we looking at here on Mars? How many different types of things that mimic the presence of life are we expected to believe in, or rather, do we simply accept the obvious? The obvious presence of active biological processes both in Mars' distant past and in the present day as well. Need more evidence? Well, what about the presence of Martian sedimentary structures that bear a great deal of resemblance to ancient microbial mats in lake systems here on Earth? As a matter of fact, the resemblance is beyond uncanny. And finally, there is one more piece of evidence, or rather a new discovery that suggests that we may have been wrong about the most fundamental thing about Mars all along, and that is, why is Mars red? For decades, it was believed that Mars's color was created by the same chemical process that creates rust on Earth, but a new paper suggests that this is not the case. A team of researchers simulated conditions of Mars in a lab and now believe that a chemical called ferrihydrite, an iron oxide that contains water, is the reason that Mars is red across the entire surface of the planet. And it looks like that the planet's characteristic red color is due to a time when all of Mars was either covered in water or subjected to water on a regular basis. The existence of ferrihydrite tells us that there were once warmer, wet conditions on Mars because that is a necessity for the formation of this mineral. It's an exciting discovery, of course, because it's one more reason to believe that Mars was once a hospitable world, and not just in limited regions, but the entire planet, which of course is why the planet is red. And it also suggests that Mars had a very active hydrological cycle, including rainfall. So that being the case, certainly Mars had life, at least in its distant past. There is so much evidence to confirm that. But what about evidence that Martian life is alive today? Well, as I've shown in this video, there's definitely a great deal of evidence to suggest that as well. And here's why it is almost certain that at least some form of life definitely survived from Mars' more habitable period until today. There is nothing about Mars' current conditions that would exterminate all life as we know it, even the high radiation. even the perchlorates that are present in Mars regolith, none of these things is enough to wipe out all types of bacteria. Indeed, there are certain types of bacteria that can survive high levels of radiation and consume perchlorates as a nutrient source and give off oxygen as a byproduct, which could explain why there's such a high level of oxygen in the Martian atmosphere, far more than we originally thought. And also keep in mind that the changes that led to Mars becoming the way it is today did not happen overnight. They took place over millions and millions of years. And as I like to say more often than extraordinary claims require extraordinary proof, is this: life finds a way. And even though the hostile conditions on Mars would have wiped out the vast majority of living things, there are many types of bacteria that, in my opinion, would have definitely evolved to survive in the long run. As a matter of fact, I can't imagine evolution not finding a way to preserve at least some kinds of life on the Martian surface. And why? Well, because that's the way life functions on Earth, and I can't imagine that our planet is unique in that regard, but rather one example of life surviving in a universe brimming over with life. Thank you very much for watching. Please don't forget to like and subscribe, and also please consider supporting this channel on Patreon. I actually have an open invitation from Dr. Levin's family. I had a chance to interview Dr. Levin before his passing a couple of years ago, but I have an opportunity to meet up with his surviving family members and get more information about his discoveries. That, of course, requires a trip to Los Angeles. And if you support me on Patreon, these are the sorts of things I can do without having to do fundraising drives. All the details are in the description, and for as little as 10 cents a day, you can support this channel and get access to a growing library of exclusive titles, which include everything from spacecraft to life on other planets to UFOs. So if you're interested in all of that, once again, it's all in the description. Thanks again for watching, and as always, stay angry about space.